Right, the circle question shows the circle with that equation, we'll see, and that line. We've got to find the corners, the centre, and the radius, and then the this distance between the circle and the line. First of all, we're going to complete the square on the x's. We need it in the correct format to get the radius in the centre. So there we go. Complete the square on the x terms. X minus 5, half that minus 10 to get minus 5, and take away the minus 5 squared. And it's the same with the y's. So it's it's y minus 4 all squared. Take away 4 squared. Don't forget the plus 32 all equals 0. And if you put all those numbers on the right hand side, we end up with just 9 here. And that's equal to 3 squared. Now it's in the right form now, because the 5 and the 4 tell me where the centre is, and 3 tells me that the radius is 3. So that's that sorted. Right. Now we're going to find the distance between the line and the circle. There's the centre. It's at 5, 4. So that's the distance that I want. I'm going to do though is find that distance between the centre of the circle and the line, and then subtract the radius. Because I don't know where. I could find out where this line hits the circle and find out what this distance is, but I'm just going to find this distance and then take off the radius. I want to call that line L dash, and the line L is that one. If I rearrange it into y equals mx plus c form, make it y equals, that tells me that the gradient of this line is a half, minus a half, which means the gradient of the red line, L dash, is equal to 2. I know it goes through 5, 4, so I can get the equation of the line by doing y minus the y value is 2 times x minus the x value, rearranging that, 2x minus 10 and the 4, I get 2x minus 6. So that's the equation of that line. I'm going to find out where this point is by solving them simultaneously. So there's the L, there's the L dash. I wrote the L like this. So I've double this one, I get 2y equals as well. Save me back with fractions. So I've got 2y equals and 2y equals. So I can put these two equal to each other, and then add an x and a 12. I get x is 6 over 5. Sub that back into this one to find out what the y value is. So the coordinates of this point are 6 over 5 and minus 18 over 5. I say what we're going to do then is find the length of this line, just using Pythagoras. Difference in the x's 5, 6 over 5. Difference of the y's 4 minus 18 over 5, so it's 4 plus. And then, but I want this distance here, so I need to subtract 3. This is 19 over 5 in the bracket there, and that's 38 over 5. I did a bit of a funny way. This is 2 lots of 19 over 5. So I'll actually take a 19 over 5 squared out of the whole thing. So that's 19 over 5 squared times 1 squared, and that's 19 over 5 squared times 2 squared. So the whole thing is 19 over 5 root 5 minus 3. You could just stick it back in the calculator, but you need to write it like that because it wants it'll probably want the exact value.